Welcome to Rogni College of Engineering. I'm Reggie, Associate Professor, Department of EC. Today we are going to see the topic impedance matching. On completion of impedance matching, students can define impedance matching, classifications of impedance matching. Impedance matching. You can see the matching network between source and load, a lossless matching network with arbitrary load impedance to the transmission line. Impedance matching or tuning is important for the following reason. Maximum power is delivered when the load is matched to the line and the power loss in the feed line is minimized. Impedance matching sensitive receiver component, antenna, low noise amplifier may improve the signal to noise ratio of the system. Impedance matching in power distribution networks such as antenna array feed network may reduce amplitude and phase error. As long as load impedance ZL has positive real part, matching network can be always found. Many choices are available. Factors that is important in selection of particular matching network include complexity, bandwidth, implementation, adjustability. Complexity. The simplest design that satisfies the required specification is generally possible. A simple matching network is usually cheaper, smaller, more reliable and lossy than a complex design. Bandwidth. Any type of matching network can ideally give a perfect match at a single frequency. In many applications, however, it is desirable to match a load over a band of frequency. There are several ways of doing this, width of course and increase complexity. Implementation. Depending upon the type of transmission waveguide being used, one of the matching network may be preferred to other. For example, tuning step must be easier to implement in waveguide than the multi-session quarter wave transformer. Adjustability. In some application, matching network may require adjustment to match variable load resistance. It is possible in some of the matching network. Impedance matching technique. Matching with lumped element, single step matching, double step matching, quarter wave transformer, tapered lines. Impedance matching. Simplest way of matching L section which use reactive element to match arbitrary load impedance. There are two possible configurations of the network. JX, JB, ZL. L section network. Network ZL is inserted between J plus X circle and network ZL outside J plus X circle. In a normalized impedance ZL by Z0 inside the 1 plus on the Smith chart. The circuit of the figure A should be used. If the normalized impedance is output 1 plus JX Smith chart, the circuit figure B can be used. 1 plus JX circle is the resistance circle of the impedance Smith chart. In either the configuration of figure, the reactive element may be a capacitor depend upon the load impedance. Thus, there are 8 distinct possibilities of matching network for with the modification resistance capacitor and resistor. Modern microwave integrated circuit may be enough such that lumped element may be used high frequency. Determination of component of matching network. Consider circuit B. So you will get the ZL outside 1 plus JX circle on the Smith chart. The admittance can be seen over the matching network 1 by Z0 JB plus 1 by RL plus JXL minus XC. If you take the real part, you will get the value of X root of RL Z0 minus Z0 into RL. So B equal to square root of ZR minus RL by RL into R0. Comparing the value, we can determine the value of B's acceptance and we will calculate the value of series reactance 1 by B plus Z0 plus RL minus Z0 plus RL. Single step matching or tuning. Another popular technique is single open circuit or short circuit length of transmission. Step is connected in either in series or parallel the transmission line field at the center from the load. Such a single step tuning is often convenient because step can be paired as the part of transmission line media and a lumped element can be avoided. Stunned step are preferred for micro strip line or strip line, while the series step are preferred for start or coplanar line. Let us see a step is placed in series or parallel to the main waveguide. So in the single step, two adjustable parameter at a distance d from the load to sub position and the value of acceptance can be provided by the step. For a step case, the basic idea is to be selected so that admittance can be looking to the line distance d from y0 plus jb. The acceptance is minus jb. For a series step, distance d is selected so that the impedance for looking forward at a distance d is z0 plus j. Sub reactance is chosen minus j. Double step matching. Single step tuner is able to match any load impedance having a real part but suffers from the disadvantage of requiring variable length. This may not be a problem for a fixed matching network, but it is probably pose difficulty in adjustable tuner. But in this case, double tuner which is used two tuning step in fixed position. So such tuner are fabricated and coaxial in the adjustable step connected in shunt with the main line. So it is contained two steps which is connected to the main line. Quarter wave transformer. The quarter wave transformer is simple and useful for matching real-time application. An additional feature of quarter wave transformer, it can be extended to multi-session design in periodically manner to get broader bandwidth. If any narrow bandwidth which is required, a single session transformer is sufficient. One drawback of quarter wave transformer can be used to real bad problem. So a single quarter wave transformer is used with Z1 is Z0 plus ZL. So these are about the matching technique, how far which is employed in most of the application. So impedance matching is very important to match the network from source to load. So the quiz questions are maximum are first, why impedance matching is used and what are the application of using this matching network.